The next massive software failure will probably not come from a missing line of code. It will come from a missing sentence. Right now, developers are using AI agents to write code faster than they can actually read it. I'm doing it too. The latest models can generate thousands of lines in seconds. But that's not the problem. The problem is that speed removes friction, and friction used to be where thinking happened. According to GitHub research, developers using AI assistants complete tasks up to 55% faster. And that sounds like a dream, until you realize that speed without direction is just a faster way to reach the wrong place. As a way to solve this problem, there is now something called Spec-Driven Development, or SDD for short. The idea is to write a clear, structured specification before the code, so that we can keep the AI speed without turning our systems into chaos. I just wondering, are we just reinventing the 1990s Waterfall methodology? But this time with an AI power engine on top? So in this video, I will cover three things. First, what SDD actually is and why vague thinking is now your biggest technical liability. Second, the three levels of SDD and the specific one that quietly traps more engineering teams. And third, a practical checklist to decide which features deserve a real spec and which one you should just build fast and move on. And by the end of this video, you will know whether SDD is a real shift in how software gets built, or just another heavyweight idea that sounds smart and wastes everyone's time. So let's dive in. So what is SDD? It is very simple. It means that the specification is the primary artifact, not the code, not the framework, not the Jira tickets. In SDD, the spec is the source of truth and everything else is downstream. That spec is not a vague paragraph or a wish list. It is a structured, testable description of system behavior. It defines what the system must do and what it shouldn't, edge cases, business rules, and very importantly, an explicit definition of done. So, in theory, that document alone, written in plain English, will be sufficient to build the complete software. Why SDD now? Well, because today AI agents can reliably translate clear specifications into working code. SDD is not new. What is new is the environment it now lives in. Code is no longer the bottleneck, it is ambiguity. Between 40 and 50% of developers' time is spent on rework due to shifting or unclear requirements. Most bugs are not code bugs. They are argument bugs. You did not write incorrect logic. You just postponed a decision until it exploded in production. Like, for example, consider a payment gateway. The requirement says the system must block risk transactions. One business analyst comes in and decides to block all transactions from high-risk countries. Another block only transactions about $1,000 or something like that. Both are reasonable interpretations, but both could be wrong in different ways. So SDD forces that decision to happen earlier, when stakeholders are calm, when assumptions are visible, and when the code base still has exactly 0 lines of code. The AI intern problem. On the other hand, right now AI agents behave like a brilliant intern who never says, "I don't understand." And that's a big problem, because if your requirements are fuzzy, it wouldn't ask clarifying questions. In order to build something useful or complex enough, we need to ask ourselves why at least 3 times. Otherwise, the agent will confidently generate a clean, professional-looking solution that could be catastrophically wrong. Another thing is that we, as humans, we have a limited capacity to transmit information. For example, we can type in average at around 40 words per minute, and that speed forces reflection. But today, AI code assistants can generate 2,000 lines of code in a few minutes, and that removes the natural pause where thinking used to happen. And when thinking disappears, ambiguity leaks straight into production. So, in my opinion, if you prompt an LLM something like, build me a login page, you could get 10 different solutions, and when your code base is full of interpretations, then this is a recipe for disaster. So SDD provides something that AI agents truly need: stable guidance. No creativity, not the speed, but constraints. The 4-step SDD workflow. Spec-Driven Development is not about writing more documentation. It is about removing ambiguity before the agent starts making decisions on its own. Here's the workflow. First, requirements. And this is the what. You describe what the user experiences from the outside, not how the system works. For example, when a user submits a support ticket, they should receive a clear and empathetic response within 5 seconds. The response must reference their issue and suggest a concrete next step. Second, design. And this is the how at a high level. You define a structure and boundaries, what information the AI agent can see, what tools it can use, and just as importantly, what it is not allowed to do. For example, the agent can read the ticket text and query an internal FAQ. It cannot invent policies, promise refunds, or escalate issues on its own. And third, task. And this is the work. Tasks must be explicit, sequential, and boring. Like, for example, first, extract the user's code problem in 1 sentence. Second, match it against the FAQ categories. Third, select the most relevant solution. Fourth, generate a response using the approved tone guidelines, and so on. No think carefully, no use best judgment. Agents do exactly what you specify, nothing more. Finally, build. And this is implementation plus automated verification. For example, does the response references the user issue? Is the tone rate as empathetic by an LLM used as it should be? Is the response under 120 words? If it fails these checks, the build then fails. And that is the entire workflow. It is intentionally simple because when working with non-deterministic tools, simplicity is not a choice, it is a reliability strategy. The 3 levels of SDD. So not all SDD looks the same. There are 3 levels based on risk. Level 1 is a spec first. You write an spec to clarify your own thinking, use it to guide the AI, then move on. And this is perfect for MVPs and experiments. An example of a tool for this is Amazon Shiro, which imposes very little emphasis on keeping the spec as a long-lived artifact across future changes of the software. Level 2 is spec anchored. The spec, in this case, is a living artifact. If the code changes, the spec must change. And this is how most high-performing teams are operating right now. An example of a tool for this is GitHub's Spec Kit, which refers spec as executable that can generate implementations. Level 3 is spec as source. You edit the spec and tools generate the code automatically. And this is the low-code dream, of course. The only example that I could find now for a tool with this characteristic is Tessel, which explicitly aims to keep specs as the core artifacts to be maintained. I personally think that level 3 is dangerous right now for complex systems. When the spec becomes the source of truth, the spec is the code base, meaning that if you cannot express your intent precisely in natural language, then a lot of ambiguity will be introduced. The reality check. So let's be honest about where SDD works and where it doesn't. SDD excelled at new features, greenfield systems, modernization efforts, when the slate is clean. Having a clear spec is a superpower. However, SDD struggles with deeply entangled legacy systems. For example, if your login is spread across 5 services, 3 Chrome jobs, and 1 senior engineer's memory, having a clear spec is almost impossible because there is too much missing context over there. The AI agent would suggest elegant refactors that ignore the decade of hacks quietly keeping the business alive. On the other hand, I personally have issues understanding so many markdown files that are generated automatically, and for me, most of the time it is actually easier understanding the code directly. But maybe this could be just because we have been developing tools for maintaining code, source code, for decades, and we still don't have the same level of tools support for SDD. And by the way, many studies now show that AI-assisted development increases code duplication and architectural drift when not constrained by explicit system rules. In other words, SDD could really help here, so I prefer to stay optimistic about it. The practical decision checklist. So, should we all use SDD tomorrow? Well, to answer this question, first run these 3-point checks. Number 1, risk. Does this touch money, security, or permissions? Then you should use SDD. Number 2, longevity. Will someone else maintain this in a year? Yes, use SDD. Number 3, exploration. Are you proving an API or testing an idea? Then definitely you just code and ignore SDD. So, in my opinion, the future isn't always spec-driven. The future is spec-driven when being run is expensive. Future or phase. So, code is becoming cheap, fast, abundant. In a world of infinite code, clarity is the scarce resource. SDD fits the new economics of software. When execution is automated, thinking becomes the bottleneck. The software industry is currently trying to figure it out how we are going to work with AI. So the teams that are going to win won't be the fastest delivering features. They will be the best communicating with AI. Because when intent is explicit, implementations becomes trivial. So now you can try this exercise. Pick one feature you want to build, and before you open your IDE, write down a one-page specification for it. Define what you want to build, the edge cases, the login and failure behavior. Then give that spec to some AI assistants like Claude Code. If the output feels cleaner, safer, and less surprising, that's not magic. It is SDD in action. Let me know in the comment if you think this approach is the future of software engineering. Thanks for watching. See you in the next one. Bye.